Question number 3.102. Two parallel plate air capacitors, each of capacitance C, were connected in series to a battery with EMF E. So there are two parallel plate capacitors having same capacitance C are connected in series across a battery of EMF E. Okay. Now, the one of the capacitor was filled up with uniform dielectric of permittivity E. Okay, so initially there was free space between the plates, but in second case, one dielectric with permittivity E filled inside the capacitor 2, let's take. Okay, so we have to find out how many times this did the electric field strength in a capacitor decreases, and number 2, what amount of charge flow through the battery. Okay, so let's see how to solve this problem. Look, initially when there was no dielectric inside the capacitor, right? So we can find out net capacitance in series combination, that is 1 over C is equals to 1 over C1 plus 1 over C2. So from here we'll get the initial capacitance, let's take C dash is equals to C by 2. And potential applied across this is EMF, that is E, and we know that the charge is stored in first case, here Q1 means case 1, is equals to effective capacitance multiplied by the potential difference. So our Q initial or Q1 is equals to C by 2 into E. This is our first equation. Now in second case, when a dielectric material of E permittivity filled in capacitor 2, then the new capacitance would be epsilon into C. So we can find out new effective capacitance of this combination. Let's take 1C double dash is equals to 1 over C plus 1 over epsilon into C. Right. So this is C square into epsilon divided by 1 plus epsilon into C. So from here we'll get C into epsilon upon 1 plus epsilon, new effective capacitance, right? So from here we can find out charge at final stage. Still same potential is applied across this. So this is epsilon C over 1 plus epsilon into E. Okay. So the net charge in first case given in equation 1 and in second case in equation 2. Now we have to find out change in electric field due to introduction of this capacitance. So for a parallel plate capacitor, electric field is equals to sigma over epsilon, right? And sigma is net charge divided by the area. So in first case, the electric field E1 will be equals to C by 2, okay, this net charge Q upon A. So C over 2 into electric field upon A into epsilon, because epsilon not we must write, because it was the free space. In second case EF, the net capacity charge is epsilon C over 1 plus epsilon into E divided by area, right, into the permittivity E. So we can calculate EF over EI. So from here we'll get the most rest of the part are common, okay, like area and epsilon naught. So we can write this is epsilon upon epsilon plus 1 into C divided by epsilon over 2 into, this is C over 2 into epsilon naught, and here also it is epsilon naught. So from here we'll get the change in electric field EF upon EI is equals to 2 over 1 plus epsilon. Okay, so this is change in electric field or ratio of electric field in final condition and initial condition, right? This is 2 epsilon 1 plus epsilon. Next, how much charge will pass through this cell? So we can calculate delta Q. Delta Q equals to QF minus QI. Here QF is epsilon C upon 1 plus epsilon into EMF minus initial charges C by 2 into E. So from here we can get that C into epsilon, C into E by 2 is equals to 2 epsilon upon 1 plus epsilon minus 1. So if we'll simplify this expression, then we'll get C into EMF by 2 into epsilon minus 1 upon epsilon plus 1. So this is charge flowing through the cell when we insert a dielectric in one capacitor.